Okay, this is topic 22, solving rational equations. So the steps that I written here for solving rational equations, we're going to go ahead and just label this as like method 1, because there are two ways that we could solve these rational equations. So in the first method, we would find a common denominator between all of the fractions, all the rational expressions, multiply everything by the common denominator to get rid of the fractions, isolate the variable, and solve. So again, I'm labeling this one as method 1. Method 2 is the one that I prefer to use the most, and the reason is the steps include first getting a fraction equal to a fraction. So fraction equal to fraction. So what that means is if we have more than one fraction on one side, we're going to have to get a common denominator between those fractions. So we are left with a fraction equal to another fraction. Then our next step would be to cross multiply. And then lastly, to solve. Because once we cross multiply, we get rid of any fractions and we're just left with a equation that we're able to solve. Okay. So what I'm going to do is I am going to do majority of them in method 2. I'll do a couple of them in method 1 so you could see the difference. And then I'm going to continue doing method 2. So looking at number 1, remember our first step is to get a fraction equal to another fraction. So notice on the left side, we already have one fraction there. But on the right side, we have two fractions. So because we have those two fractions, we're going to have to get a common denominator between these two, so we're able to subtract them and make it one fraction. So looking at the denominators, we have a 3k and a k, which means the common denominator between both would be 3k. So the only one missing something is this fraction here. So I'm going to multiply that fraction top and bottom by 3. And then I'm left with 1 over 6k squared is equal to 1 over 3k minus 3 over 3k. Okay. Now I'm able to combine that fraction on the right side. So 1 minus 3 is negative 2. So I have 1 over 6k squared is equal to negative 2 over 3k. Okay. Once I have a fraction equal to a fraction, so notice both left and right side, I am now going to cross multiply. When I cross multiply following the green path first, I have 6k squared times negative 2 is equal to, now I'm following the pink path, 1 times 3k. Okay, notice when I did this, I got rid of all of my fractions. So now I'm simplifying. 6k squared times negative 2 is negative 12k squared, is equal to 1 times 3k, which is 3k. In order to solve this, we're going to have everything equal to 0. So I'm going to subtract that 3k over, and I get negative 12k squared minus 3k is equal to 0. Since I only have the a and b value of a quadratic equation, this tells me I'm going to take out a GCF. And the GCF I can take out here is a negative 3k. And I'd be left with 4k plus 1. Okay. Now that I have that factored, according to the zero product property, I can set each one separately equal to 0. So I have negative 3k equals 0 and 4k plus 1 equals 0. Well, negative 3k equals 0. means I just divide both sides by -3 and I'm left with k is equal to 0. And then on the other one, I have to subtract 1. So I'm left with 4k equals -1. And then divide by 4. And I have k is equal to -1/4. Remember, I can't consider these my answers because in my original problem, I do have my variables in the denominator. So I'm going to have to check my work to make sure both these solutions make sense. So first I'm checking the k equals 0. So anywhere I see a k, I'm going to plug in a 0. So 1 over 6 times 0 squared equals 1 over 3 times 0 minus 1 over 0. Notice when I do that and I simplify all these denominators, I get 1 over 0 is equal to 1 over 0 minus 1 over 0. We cannot divide by 0, so these are undefined. So this tells us that our answer of k equals to 0 is not possible. Okay? Now we're checking the next part, that k equals to -1/4. So anywhere I see a k, I'm going to be putting in a -1/4. And all we need to check here is to make sure that our denominator does not go to 0. Okay? Notice if we check every single one, okay, if I square that -1/4 and I multiply by 6, that's not going to give us 0. 3 times -1/4, that's not 0. And -1/4, that's not 0. So that means that k equals -1/4 is our only possible answer. Okay. So now let's look at number 2. Using that same method, remember my goal is to have a fraction equal to another fraction. So on my right side, I already have one fraction. But on my left side, I'm going to have to find a common denominator and then combine them. So notice that I have 6b squared and then I have 6b. Meaning if I'm finding a common denominator between both of them, I'm looking which one is missing something. They both have 6's. They both have at least one b, but this fraction is missing an additional b. So I'm going to be multiplying the top and bottom by b. So I have 1 over 6b squared plus b over 6b squared is equal to 1 over b squared. Okay. Now I can combine my numerators. So I have 1 plus b over 6b squared is equal to 1 over b squared. Okay. I'm going to go ahead and put that 1 plus b in parentheses, just to know that this all goes together. So now that I have a fraction equal to another fraction, I am going to cross multiply. So I have b squared times 1 plus b is equal to 6b squared times 1. Okay. Now I'm going to simplify this out now that my fractions are gone. And I have this b squared outside of the parentheses. So that tells me I'm going to FOIL that in. And I get b squared plus b cubed is equal to 6b squared. Okay. Remember, I want everything over to one side and equal to 0. So I'm going to subtract 6b squared to the other side. And I get -5b squared plus b cubed is equal to 0. Okay, this is another one where it looks like we're just taking out a GCF in order to factor. So that means the most I can take out of both of these would be a b squared. So b squared, and I'm left with -5 plus b is equal to 0. Then I'm going to set each one equal to 0. So b squared equals 0. -5 plus b equals 0. b b squared equals 0, take the square root of both sides, and I get b is equal to 0. Add 5 to the other side, and I get b is equal to 5. Okay. Remember, this is not my answer. I still have to check to make sure none of these choices make my denominator 0. So here's my check. First, I'm plugging in 0. 1 over 6 times 0 squared plus 1 over 6 times 0 equals 1 over 0 squared. Notice how every single one of these turn the denominator 0, so b equals 0 is not an answer. Now we check b equals 5. So anywhere I see a b, I'm plugging in a 5. Okay. And then notice once I multiply those ones out, none of them give me 0. So that means b equals 5 is an answer, but b equals 0 gives us something that's undefined. Okay. Now let's look at number 3. Okay. So again, let's do that fraction equal to another fraction. So we have a fraction on this side, but we have 2 terms on this side. So that means before we can even find a common denominator, we're going to have to turn that 1 into a fraction. And remember, we do that by writing it over 1. So now it's 1 over 1. So between 5x and 1, our common denominator is going to be 5x. So that means I need to multiply that 1 over 1, top and bottom, by 5x. So I'm left with 1 over x is equal to 6 over 5x plus 5x over 5x. Combining like terms, I have 1 over x is equal to 6 plus 5x over 5x. Now I have a fraction equal to a fraction, so I'm going to cross multiply. So I have 5x times 1 is equal to x times 6 plus 5x. That x outside of the parentheses tells me I'm going to distribute. So I have 5x is equal to 6x plus 5x squared. Okay. I need to have this all equal to 0, so I'm going to move my 5x over. And I have x plus 5x squared equals 0. Okay. Taking out a GCF, I'm going to take out an x, and I'm left with 1 plus 5x equals 0. Set them both equal to 0. And then solve. My one answer, I got x is equal to 0. And in the next one, I got x is equal to negative 1/5. Okay, so now let's just go back and let's do a mental check. Okay, if we were to plug in 0 into these denominators here, would they be 0? Correct, they would be 0. So that means that we're going to get an undefined answer, so x equals 0 is not possible. Now, let's see if we plug in negative 1/5. So negative 1/5 here, that's not going to make it 0. And negative 1/5 here, negative 1/5 times 5 is just negative 1, so that's not going to be 0. So that means this is an answer. So that means the only answer we have here is x equals negative 1/5. So you could kind of see the trend going on here, where if we get an answer equal to 0, more than likely, that is not going to be a possible choice because it's going to give us an undefined answer when we look at our fractions. Okay, so keep that in mind. Okay, looking at number 4. Okay, number 4, again, we want a fraction equal to another fraction. Okay. Notice how we have one fraction here and we have two fractions here. So we could do one of two things. We could try to make this one fraction by getting a common denominator, or notice how these denominators already match. So I could go ahead and move this entire fraction over, simplify, and I wouldn't have to worry about getting a common denominator. So that's what I'm going to do. So I am subtracting 3v plus 12 over v squared minus 5v. I'm subtracting that whole amount over to the other side. So I'm left with 1 over v is equal to 7v minus 56 over v squared minus 5v minus 3v plus 12 over v squared minus 5v. Okay. Notice I have a common denominator, so all I need to do is subtract the numerators. So when I do that, I'm left with 1 over v is equal to 7v minus 56 minus 3v minus 12 all over v squared minus 5v. Simplifying this, I have 7v minus 3v, which is 4v, and negative 56 minus 12, which is negative 68, all over v squared minus 5v. Now I have a fraction equal to a fraction, so I'm going to cross multiply. So I have 1 times v squared minus 5v is equal to v times 4v minus 68. Okay. I am going to go ahead and distribute that v in. So I'm going to have v squared minus 5v is equal to 4v squared minus 68v. We want everything equal to 0, so I'm going to move the negative 4v squared over, and I'm going to move that positive 68v over. So I have v squared minus 4v squared minus 5v plus 68v equals 0. Okay, I just moved them all to the other side. Now I'm combining like terms. So v squared minus 4v squared is negative 3v squared, and negative 5v plus 68v is a positive 63v equals 0. Okay. Now I'm taking out a GCF, and it looks like I can take out a negative 3v, and I would be left with, let's see, v minus 21 equals 0. Okay. Then I'm going to set each one separately equal to 0. So negative 3v equals 0 means I have v equals 0. V minus 21 equals 0 means I have v is equal to 21. Okay. Again, and acknowledging the trend that we keep seeing with our answers of 0, notice if we plug in this 0 back into these fractions, it's going to make each of these denominators 0, which is causing the problem to be undefined. So we know this is not an answer. Okay. But if we check 21 and we plug in 21 into each of these denominators, we're just going to get a number. And that number is not going to be 0. So that means their answer is v equals 21. It's always good to double check, though, for both, because it could be a possibility where neither of your answers are correct. And so that would leave us with a no solution. Okay. Let's look at number 5. Okay. On number 5, I'm going to go ahead and switch it up, and I am using method 1, just so you're able to see both methods, okay? Remember in method 1, our first step was to make sure everything had a common denominator, okay? So we have an n minus 8, an n minus 8, and then we just have to turn this 1 into a fraction and give it the denominator of n minus 8. So I'm going to write this over 1, and then multiply the top and bottom by n minus 8. So I have 1 over n minus 8 is equal to, minus 1 times n minus 8 over n minus 8 is equal to 7 over n minus 8. Okay. Notice that I have a common denominator on each one. Now that I have that, I'm going to multiply this entire thing by n minus 8. And what that's going to do is that's going to get rid of all those fractions. So that means I'm left with 1 minus n minus 8 is equal to 7. Okay. Distributing that negative n, I have 1 minus n plus 8 is equal to 7. Now I'm just getting n by itself and solving. So I have a 1 and an 8, so that's a 9. So I have negative n plus 9 equals 7. Subtract 9 to the other side, and I get negative n is equal to negative 2. Divide by negative 1, I get n is equal to 2. Okay. I still have to check if that 2 does not turn any of these denominators to 0. So if I plug in a 2 here, 2 minus 8, that gives me negative 6. Same over here, 2 minus 8 gives me negative 6. Since it does not give me 0, then n equals 2 is my answer. Okay. Again, this is me showing you method 1. Okay. On number 6, let's go ahead and do method 1 again. And then from then on out, I'm just going to go ahead and do method 2 because that's what I prefer. But you could choose to do either method. So in number 6, we are also doing method 1, just so you have these to refer back to if you like this one better. Okay, remember our goal is to make sure we have a common denominator between all of them. So we have a v minus 4, and then this one over here that we need to turn into a fraction with v minus 4. So first turning it into a fraction by writing it over 1. And then since they all have v minus 4 as their denominator, we're going to multiply the top and bottom by v minus 4. So I have v minus 4 over v minus 4 is equal to v plus 2 over v minus 4 plus 7v minus 42 over v minus 4. Okay. Now I have a common denominator between all of them. Once I have that common denominator, I'm going to multiply the entire equation by that denominator. And what that does is it cancels out all the denominators. So then I'd be left with just the numerators. V minus 4 is equal to v plus 2 plus 7v minus 42. Now I'm just combining like terms and getting v by itself. So I have v minus 4 is equal to, I have a v and a 7v, so that's 8v, and a 2 and a negative 42, so that's a negative 40. And then I'm going to go ahead and subtract the 8v over. So I'm left with negative 7v minus 4 is equal to negative 40. Add the 40 over. And I'm left with negative 7v plus 36 is equal to 0. Okay. I'm going to subtract that 36 over, which I could have done on a few steps prior. but we get the point. We're solving for the variable, getting it by itself, and then dividing both sides by that -7. So I'm left with V is equal to 36/7, or the equivalent in decimal form is about 5.14. Okay. If I plug in that 5.14 into this right here, I would have 5.14 minus 4, which is not 0. Since I do not get 0, this is my answer. Okay. Okay, now let's look at the next example. Number 7. Okay, now I'm going back to the method 2 because that's the method that I prefer. Okay, so I need a fraction equal to another fraction. Notice that I have common denominators, but they're on opposite sides of that equal sign. Well, instead of trying to get that 1 to have a common denominator, I am just going to go ahead and move this entire fraction over to the other side. So I have 1 equals x minus 6 over 3x minus x squared minus 5x minus 24 over 3x. Since they already have a common denominator, I'm going to combine like terms. So I have 1 is equal to x minus 6 minus x squared minus 5x minus 24 all over 3x. Okay, the reason I'm putting that second part in parentheses is because of that negative. Because that negative is going to change all the signs. Okay, so this negative is changing all the signs here. So I'm left with 1 is equal to x minus 6 minus x squared plus 5x plus 24 all over 3x. Okay, I'm going to combine like terms at the top. So I have my x's and then I have my constants. So 1 is equal to, looks like negative x squared plus 6x plus 18 all over 3x. Remember, I can turn that 1 into a fraction by putting it over 1. So now I have a fraction equal to another fraction. So I'm going to cross multiply. So looking at the green line, I have 1 times that quadratic. 1 is not going to change it, so I'm just going to write the quadratic. Negative x squared plus 6x plus 18 is equal to 1 times 3x, which I can just write as 3x. And since this is a quadratic, I want this equal to 0, so I'm going to subtract the 3x over. And I have negative x squared plus 3x plus 18 equals 0. Okay. I don't like dealing with that negative in front of that x squared. So I'm going to go ahead and multiply this whole thing by -1. And all that's going to do is change the signs. So I have x squared minus 3x minus 18 equals 0. Now when I look at this, I have my a, my b, and my c value. Okay. Since it is a quadratic equation, I'm going to use the AC method to factor. Okay. So I'm going to be going up here, doing my A times C method. So A times C is -18. Okay. And my B is -3. Okay. So I need two numbers that multiply to -18, but add to -3. So let's see. We have 6 and 3 gives us 18, but negative 6 and 3, if we multiply, gives us negative 18, and if we add, gives us negative 3. Okay, so those are going to be our numbers. So once we have those, remember we plug them in and we do factor by grouping. So I'm just going to have x squared minus 6x plus 3x minus 18 equals 0. And I'm going to zoom in right here. Then I do my factor by grouping and take out a GCF from each. So I have x, and I'm left with x minus 6. And then I can take out a 3, and I'm left with x minus 6. Remember, I want those parentheses to match. So then I have x minus 6 and x plus 3 equals 0 as my factors. I'm going to set each one equal to 0. So x minus 6 equals 0 gives me x is equal to 6. And x plus 3 equals 0 gives me x is equal to negative 3. I still need to double check that neither of these numbers will give me 0. So if I do 3 times 6, that's not 0. And 3 times negative 3, which is negative 9, which is again not 0. So that means that this time we have two answers. We have x equals 6 and x equals negative 3. Okay. Let's go ahead and look at number 8. Okay. Notice on number 8, we need to get a fraction equal to another fraction. But in this case, if we look at our two fractions, we don't have matching denominators. So that means what we're going to have to do is we're going to have to create that matching denominator with the 1. So looking at just at this side, I'm going to turn the 1 into a fraction. And I want to get a common denominator of n plus 1. So I'm going to multiply that 1 over 1, top and bottom, by n plus 1. So I have n plus 5 over n plus 8 is equal to n plus 1 over n plus 1 plus 6 over n plus 1. Okay. So that gives me n plus 5 over n plus 8 is equal to n plus 1 plus 6. So n plus 7 over n plus 1. Okay. Now I have a fraction equal to another fraction. And notice when I cross multiply this time, I have two binomials. So n plus 5 times n plus 1 is equal to n plus 8 times n plus 7. Two binomials. And remember, when I see two binomials that are being multiplied, we need to use the FOIL method. So we're going to FOIL these out. Okay. And we're going to end up with two quadratics equal to each other. Okay. So n times n is n squared. N times 1 is n. 5 times n is 5n. 5 times 1 is 5. N times n is n squared. N times 7 is 7n. 8 times n is 8n. And 8 times 7 is 56. Okay. Combining like terms, I have n squared plus 6n plus 5 is equal to n squared plus 15n plus 56. Okay. Even though we have two quadratics, we want them still equal to 0. So I'm going to move the quadratic that's on the right side over to the left. So I'm going to subtract n squared. Notice those cancel. I'm going to subtract 15n, and then I'm subtract 56. Okay, So that means I'm left with negative 9n minus 51 equals 0. I'm going to add 51 to the other side because I want to get n by itself. And I get negative n is equal to 51. Divide both sides by negative 9. And I got n is equal to negative 51 ninths. Or if I plug that into my calculator, that's equivalent to negative 5.67. And if I was to plug in that negative 5.67 into either of these, I would not get 0. Remember, that's what we're checking for. I would not get 0, which means this is my answer. Okay. I'm going to go ahead and leave 9 for self-practice. And then if you want to check, you should get x equals 5.14 or 36/7 as your answer. Okay. Number 10, we're going to go ahead and do together. And same thing, we want a fraction equal to another fraction. So notice this time that we have these two that are matching denominators. So instead of trying to get this as a common denominator, we're just going to move this fraction over to the left by subtracting it. So I have p plus 5 over p squared plus p minus 1 over p squared plus p is equal to negative p minus 6 over p plus 1. Okay. Since we now have the two fractions with the common denominator, I'm going to go ahead and combine them. So this is p plus 5 minus 1. So that's p plus 4 over p squared plus p is equal to, and I'm going to go ahead and distribute that negative in so there's no confusion later on. So I have negative p plus 6 over p plus 1. Okay, I'm going to cross multiply. And again, this is going to be almost like that binomial times another binomial. So I have p plus 4 times p plus 1 equals to p squared plus p times negative p plus 6. Okay. And then I'm going to FOIL. Okay, so when I FOIL, remember some things could potentially cancel. So we're just going to do each side separately. P times p is p squared. P times 1 is p. 4 times p is 4p. 4 times 1 is 4. P squared times negative p is negative p cubed. P squared times 6 is plus 6p squared. P times negative p is negative p squared. P times 6 is 6p. Okay, we want this all equal to 0, so I'm going to move everything that is on the right side over to the left side. So I'm going to be adding a p cubed, subtracting a p squared, adding a p squared, and subtracting a 6p, so I get 0. So that's the way this goes away. So I have p squared plus p plus 4p plus 4 plus p cubed minus 6p squared plus p squared minus 6p equals 0. There's a lot of terms here, so in order to combine like terms, I'm going to just highlight all the ones that are similar. So here's all my p squares. Here's my p's, and then it looks like I just have one constant and one p cubed. So that means I have p cubed, and then p squared plus p squared is 2p squared, minus 6p squared is negative 4p squared. Okay, now looking at the p's, I have p plus 4p, which is 5p. 5 minus 6p is negative p, and then plus 4 equals 0. Notice I have 4 terms. Because I have 4 terms, I can do the factor by grouping. So in the first one, I can take out a p squared, and I'm left with p minus 4. And since I want my parentheses to match, I'm going to take out a negative 1, so I have p minus 4. So I have p minus 4, and p squared minus 1 equals 0. Notice that p squared minus 1 equals 0, this section right here, this is a perfect square, which means I can factor it even further. Remember, I do my 2 parentheses. I write a p in each. 1 is plus and 1 is minus. And then I take the square root of that c value. So the square root of 1 is 1. And then bring down that p minus 4. So now here I have 3 factors that I'm setting equal to 0. So I have p minus 4 equals 0, which means p is equal to 4. I have p plus 1 equals 0, which implies p is equal to negative 1. And p minus 1 equals 0, which implies that p is equal to 1. So I'm going to have to check all those numbers, 4, negative 1, and 1, and see if any of them make my denominators up here 0. So if I plug in 4, 4 looks good. 4 looks like it's just going to give me a larger number. If I plug in negative 1 squared is 1. 1 minus 1 is 0. So that turns that to 0 right away. So we know that this is not a possibility. Okay, let's check 1. 1 squared is 1 plus 1 is 2. So that works. So that means my answers are 4 and 1. Okay, I'm going to go ahead and leave 11 as self-practice. To check, you should get the answer n equals 1/2. Okay, let me see this one too. I'm going to go ahead and leave 12 as self-practice. And if you did it correctly, you should get b equals 4. Okay. Just checking through any of them, seeing if there's any that we didn't look at the concept for. Okay, I'm going to do the same with 13 and 14. Leave these as self-practice. You should get x equals negative 2 here. And then self-practice. Just because I put so many problems on this note sheet. You should get m equals 5 here. Okay, now let's look at 15. Okay, remember in 15, we want a fraction equal to another fraction. So notice that we have common denominators here, but they're on opposite sides. So I'm going to go ahead and move this 1 over r minus 2 over to the right. I'm going to do that by subtracting. So I have 1 over r squared minus 7r plus 10 is equal to 6 over r minus 2 minus 1 over r minus 2. So if I was to combine these fractions, 6 minus 1 is 5. So I have 1 over r squared minus 7r plus 10 is equal to 5 over r minus 2. I have a fraction equal to a fraction, so I'm going to cross multiply. So I have 5 times r squared minus 7r plus 10 is equal to 1 times r minus 2, so just r minus 2. Okay. I'm going to distribute that 5, so I have 5r squared minus 35r plus 50 is equal to r minus 2. And I'm going to move everything that's on the right side over to the left because I want it equal to 0. So I'm going to subtract r and add 2. So I have 5r squared minus 36r plus 52 is equal to 0. Okay. From here, I'm first going to see if I can take out a GCF. So between the numbers 5, negative 36, and 52, there's not a number I'm able to take out. So I'm going to go straight to my AC method. So A times C is 5 times 52, which is 260. And our B value is negative 36. Okay. So I can't think of this at the top of my head, so I'm just going to write out some factors. I have 1 times 260, 2 times 130, 4 times 65, 5 times 52, and 10 times 26. So it looks like that 10 times 26 will work if I make them both negative. So I'm going to have a negative 10 and a negative 26. Okay. So then I have 5r squared minus 10r minus 26r plus 52 is equal to 0. Factor by grouping. In the first one, I'm taking out a 5r, and I'm left with r minus 2. And the next one, I'm taking out a negative 26 and left with r minus 2. So I have the factors r minus 2 and 5r minus 26 equals 0. So r minus 2 equals 0 means that r equals 2. And 5r minus 26 equals 0. I have 5r equals 26. So r is equal to 26 fifths, or 5.2. Okay. So I have to check if 2 and 5.2 will make any of these 0. Okay, so let's look at 2. If I plug in 2 into this first one, 2 minus 2 is 0. Right away, that gives us 1 over 0, which is undefined. So this is not an answer. Now let's check 5.2. 5.2 minus 2, that's good. That's going to work. Let's see. 5.2 here, that's just going to give us a larger number. And then this one's going to be the same as the first. So that means my answer is that 5.2. Okay. Let's look at 16. Okay, again, we need a fraction equal to a fraction. So I am going to go ahead and move this one over by subtracting. So I have r minus 4 over 5r is equal to minus 1 over 5r. Because remember, I moved that 1 with the common denominator over to the left side, is equal to 1. Combining the numerators, we have r minus 4 minus 1. So that's r minus 5 over 5r is equal to 1 over 1. Cross multiply. We have r minus 5 times 1, which is just r minus 5, is equal to 5r times 1, which is 5r. Okay, I want to get r by itself, so I'm going to go ahead and subtract r over, and I get negative 5 is equal to 4r. Divide by 4, and I get r is equal to negative 5/4. if I plug in negative 5/4 into the r value here, 5 times negative 5/4 is just negative 25/4. It's not going to give us a 0, so that means our answer is that negative 5/4. If we were to have plugged it in and it gave us 0, which means it's undefined, and we have no other answer to check, then that means there would be no solution for this problem. Okay. 17, I'm going to leave a self-practice. You should get x equals negative 1. Let's look at 18. Okay. Again, we need a fraction equal to a fraction, and notice how these have common denominators, but they are on opposite sides. So I'm going to move this one over so we can combine those two fractions. So I have negative 1 is equal to 1 over r squared minus 2r minus r plus 5 over r squared minus 2r. Okay. Combining the numerators, now that we have common denominators, 1 minus r plus 5, that minus has to distribute in. So we would have 1 minus r minus 5, which would become negative r minus 4. Okay, negative r minus 4. So we have negative 1 over 1 is equal to negative r minus 4 over r squared minus 2r. Okay, then we're going to cross multiply. So we have negative 1 times r squared minus 2r is equal to 1 times negative r minus 4. So again, I'm going to have to distribute that negative 1, and I get negative r squared plus 2r is equal to negative r minus 4. Since I have that r squared in there, that means I need to have everything over to one side and set equal to 0. So I'm going to add r and add 4. So I have negative r squared plus 3r plus 4 equals 0. Okay, I don't like having that negative in the front as my a value, so I'm just going to switch the signs. So r squared minus 3r minus 4 equals 0. Remember, that's the same as me multiplying this whole thing by negative 1. Now that I have a quadratic equation, I'm going to do my AC method. So 1 times negative 4, which is negative 4, and my v value, which is negative 1. So I need two numbers that multiply to negative 4, but add to negative 3, and that's going to be negative 1 times 4. Rewrite this, r squared minus r plus 4r minus 4 equals 0. Do my factor by grouping, and I have r that I can take out of the first one, and I'm left with r minus 1. And the next one I can take out of 4, left with r minus 1. So I have r minus 1 and r plus 4 equals 0, which means r minus 1 equals 0 gives me r is equal to 1, and r plus 4 equals 0 gives me r is equal to negative 4. Okay, now I need to plug those in to make sure I don't get 0. So starting with 1, 1 squared is 1, minus 2 times 1, 1 minus 2, negative 2. Okay, that doesn't give me 0, so that one's good. Now trying negative 4. Negative 4 squared is 16, minus 2 times negative 4, which is plus 8. Okay, again, 16 plus 8, going to give me a number that's not 0. So these are both my answers. Okay. And then the last two I'm going to leave as self-practice. The process is just so repetitive here. So for this one, if you got the answer right, it would be A is equal to negative 19 over 8, which is approximately negative 2.38. And then for number 20, you should get N is equal to negative 1/4.